Hello. In this video, we're going to be discussing the time value of money concept, specifically solving for unknown variables when it comes to present value of annuities. We've seen this slide before in previous videos, but just a quick review, an annuity is when you have a series of cash flows of payments, whether they're paid or received, they are the same amount over a period of time, and they can occur, the cash payment can occur at the end of each period, which is called an ordinary annuity, or they can occur at the beginning of each period, which is called an annuity due. To solve for unknown, when you have an unknown variable, whether that's the interest rate or the annual installment amount or the number of periods, it's really an algebraic equation that you have to solve for x. So we'll go through it. But just remember, when we are solving for a present value of an annuity, right, whether it's an annuity due or annuity due or an ordinary annuity, the present value is equal to the installment amount, right? Whatever you have to pay every month, year, quarter, times the factor. And the factor comes from the factor table based and also based if it's an annuity due or an ordinary annuity. Just want to kind of put that out there so you'll see why. Assume you borrow $700 from a friend, and instead of repaying the amount in assume you borrow $700 from a friend and intend to repay the amount in 4 equal installments beginning 1 year from today. So if we have a lapse in time 1 year from today, we know we're going to be dealing with the present value of an ordinary annuity. Your friend wishes to be reimbursed for the time value of money at an 8% annual rate. What is the required annual payment that must be made, which is the annuity amount, to repay the loan in 4 years? So our facts are that I'm gonna borrow $700 from my friend today. I'm going to repay my friend over the next 4 years, starting at the end of the first year. And I'm gonna, so it's my number of periods is 4. I'm gonna be paying an 8%, but what amount am I gonna be paying my friend each of those 4 years? So remember this formula right here. So my present value of the annuity, we know that's $700, that's given. The installment amount is, we'll call it X, we don't know, times the factor. The factor we do know. We know we need to do a present value of an ordinary annuity with n equals 4 and I equals 8. So if we go to our factor tables of n equals 4, I equals 8, and I'm going to look at my present value for an ordinary annuity, n equals 4, I equals 8, 3.31213. So if I go back here, if I go into my slide, let me just back to my equation. I have my $700, right, equals my some annuity amount, which is X, times the factor, which is 3.31213. So if I just divide both sides by that number, by 3.312, right, my equation is going to be $700 divided by this factor amount, and now have my annuity amount is $211.34. So I have to pay my friend $211.34 at the end of each year, the next 4 years, if I want to borrow $700 today. Another example is, assume you're still borrowing $700 from a friend and intend to repay the amounts in equal installments of $100. So in this situation, we know the present value and we know the annuity amount, the installment amount, right? Is it called the annuity amount? So we are going to intend to repay equal installments of $100 per year over a period of years. That's going to be what we need to solve for. The payments will be made at the end of each year, so we're dealing with present value of an ordinary annuity beginning 1 year from now. Your friend wishes to be reimbursed for the time value of money at a 7% annual rate. How many years would it take before you repaid the loan? So I have, I'm going to borrow $700, right? And I will give $100 at the end of each year with a 7% rate, but I don't know for how many years. But I know my formula is going to be the present value, this present value number, equals 100 times the present value of an ordinary annuity factor. So what I'm going to do is I'm going to divide both sides by 100, right? And so I'm going to get that when I divide both sides by 100, my new formula is that 7 equals the present value of an ordinary annuity factor. So my present value of ordinary annuity factor is 7. And that is made up of, I know it's a 7% interest rate, but I don't know what's the number period. What I'm going to have to do is go to my present value of an ordinary annuity table, look under the 7% column, and find the factor table that's closest to 7.0. Let's see if we can do that. So 7%, and this is the present value of an ordinary annuity, which here it is, so we're still here. And the numbers, the interest rate is 7%. And let's look where we can find a factor of 7. Now, you see here, when I look at my n equals 10, right, at 7%, it's 7.02358. And the next one down, if I went to 11 periods, it's 7.4. So I'm going to choose, it's really close to the n equals 10. I'm going to say that it is over a 10-year period. And that's exactly what we see here. We determined that 7.0 is closest to, it would take about 10 years. So it's not exactly 10 years, but more or less 10 years to repay that loan. Okay, let's determine the rate when other variables are known. So now we're going to solve for the rate, like what rate are we going to use? Suppose a friend asked to borrow $331 today, so it tells you that's a present value, and promised to repay you $100, the annuity amount, at the end of each of the next 4 years. So we know we're going to deal with present value of an ordinary annuity. Just as easily, if this said at the beginning of the next 4 years, it would be present value of an annuity due, and we would just, when we're solving for this rate amount, we would just use a different factor table. We would just look to the different factor tables. That's the only difference. But anyways, this is at the end of each of the next 4 years. What is the annual interest rate? So now we're looking for the interest rate. So here are our facts, right? We have a present value of today of 331, 4 payments of $100 at the end of each year. So we know my number of periods is 4, and what's my interest. So because I know that my present value equals my annuity amount times my factor, and I have my present value amount and I have my annuity amount, I can take 331 divided by 100, because if I divide both sides by 100, I have my factor is 3.31. So what I'm going to do is I'm going to go to my present value of an ordinary annuity, look at the row that has n equals 4. I don't know which interest rate, but I'm going to look for a factor that most closely matches 3.31, and that will tell me what the interest rate is. So let's look at my factor table for, here's n equals 4, right? Here's my present value of an ordinary annuity, n equals 4. I'm trying to figure out the interest rate, and I'm looking for 3.31. So I go here, I can see that they're going down and down, and here at 8%, I have 3.31213, which is 8%. So let's just go back here. That's the closest to the 3.31. And so I say that my interest rate is 8%. You know, when you take out the decimals, maybe it's 8.042, but essentially it's 8%. I'm hoping that you guys can see the pattern here, that it's we're just solving for x, and then the x is usually the factor table, and then if we have 2 out of the 3 components that make the factor table, we can figure out the third component, right? Because the factor table is made up of the factor, of the interest rate, and of the number of periods, or number of periods. And so if we have 2 out of these 3 items, we can figure out the third. And that's all we're doing here. Let's take this last example. On January 1, 2027, the shoe company purchased a $35,000 machine with $5,000 down and a 5-year installment note for the remaining $30,000. The terms of the note call for an annual installment payments at the beginning, with the first payment due on January 1, 2027. So this is going to be the present value of an annuity due. So the first payment is due on January 1 and at each December 31 thereafter. Assuming an interest rate of 4%, what is the annual installment? Well, first you have to see what are we looking for as the installment amount. We put $5,000 down, so we have a purchase price of $35,000, but we put $5,000 down. So we're really just trying to find out, when we look at our table, if we're going to look at our, let's just say our table, our present value amount is $30,000. That tells us, okay, if I invested $30,000 today over how much did it tell us? Over 5 years, right? 1, 2, 3, 4, 5. And I need to make, and I earn 4%. What's my installment like each one of these years? It's not 35 because 5,000 just down. It's the 30,000 is what we're paying in the installment, in installments. So again, the present value of the present value equals the annuity amount times the factor. So we know the present value is 30,000. We don't know the annuity amount. That's going to be X, but we know the factor. We know the factor is over a 5-year period and 4%. So we would go into our factor table for the present value and annuity due, look at n equals 5, I equals 4, and I'm not going to do it again, but it's going to be 4.6299. So times 4.6299. So if I want to just solve for x, right, and get x on one side, I'm going to divide both sides by the 4.6299. So that's how I get my 30,000 divided by 4.6299, and I get an installment amount of $64.80. So I would need to pay $64.80 for the next 5 years at the end of each year. Sorry, at the beginning of the first year and then 1 year thereafter. If I want to journal entry that, I would say debit machine costs $35,000. I put $5,000 down, so I credit my cash, and then I have a notes payable for $30,000, right? Because I'm going to pay in installments, so I still owe that to the store where I bought my machine. And so when I pay my first installment, of 66,480, I'm going to debit my notes payable and credit my cash. And that's going to be for each of the notes installment amount.